This is chapter 2, number 59. The question's premise is that two students are on a balcony 19.6 meters above the street, and one student throws a ball vertically downwards at 14.7 meters a second, and in the same instant, the other student throws the ball upwards at the same speed. The second ball misses the balcony on the way down, which means that both balls just go straight up and down or just straight down, so there's no sideways movement. So the three things we need to find are A, what is the difference in the two balls' time in the air? B, what is the velocity of each ball as it strikes the ground? And C, how far apart are the balls exactly 0.8 seconds after they are thrown? So here's my sketch. I put upwards as a positive direction. I made 0 as where the balls are thrown, like the second they release the hands. And then I labeled the ground as 19.6 meters from the balls thrown, as you can see here in the question. So the two balls, I named one ball D for downward, and then the other one ball U for upward. So ball D, we know the initial velocity to be negative 14.7 meters a second. We don't know the final velocity. We know the acceleration of gravity is negative 9.8 meters a second squared. We don't know the time yet, and we know the total displacement will be negative 19.6 meters, since it'll go 19.6 meters down when it eventually hits the street. Ball U for upwards has an initial velocity of positive 14.7 meters a second. We don't know the final velocity of this one either yet. The acceleration of gravity is still negative 9.8 meters a second squared. We don't know the time of this one either, and it will also end up on the ground negative 19.6 meters from the start. So we're trying to find the air time now. So the ball D air time, I used the equation without final velocity, so equation 3, which is the total displacement is equal to the initial velocity multiplied by time plus 1/2 of the acceleration multiplied by time, so time squared. So I put all the elements or all of the numbers on one side to make it all equal to 0, because I'm going to have to use the quadratic formula for this since it has a t squared. So then I substituted it all in, which makes it 1/2 multiplied by negative 9.8 meters divided by second squared times time squared plus quantity of negative 14.7 meters a second times time minus negative 19.6 meters. So if you simplify that, then you end up getting negative 4.9 meters a second squared times time squared minus 14.7 meters a second times time plus 19.6 meters. Then I did two things then. I divided the whole thing by meters, because just to make it simpler and not have like a bunch of variables in the formula. And then I put time over seconds, because it makes an easy times over seconds squared and then times over seconds to 1, and then there's no time or seconds in 19.6, so that in the formula I don't have any variables, only numbers. So then this is the quadratic formula, which is x equals negative b plus or minus the root of b squared minus 4ac all over 2a. So I replaced everything in, which made for t over s is equal to 14.7 plus or minus the square root of negative 14.7 squared minus 4 times negative 4.9 times times positive 19.6. All of this over 2 times negative 4.9. So then you simplify it a bit to get, you square negative 14.7 to get negative 216.09, and then you multiply negative 4, negative 4.9, and negative 19.6, all to get positive 384.16. And then you multiply negative 4.9 by 2 to get negative 9.8. So then you have 14.7 plus or minus the square root of 216.09 plus 384.16, all over negative 9.8. Then I added the two quantities in the root together to get 14.7 plus or minus the root of 600.25 all over 9.8, negative 9.8, sorry. And then I took 600.25 out of the root, so I got 14.7 plus or minus 24.5 over negative 9.8. So because it's a plus or minus, you have two choices. I did both of them. So now we have t over s is equal to 14.7 plus 24.5 over negative 9.8, or we have t over s is equal to 14.7 minus 24.5 over negative 9.8. So the plus doesn't work because if you add them, then you'll end up getting, you can see here it adds to 39.2 divided by negative 9.8, which makes into t over s equals negative 4. And you can't have any negative seconds because that doesn't exist. So that just doesn't work. And then the other side, you'll end up getting 14.7 minus 24.5 is equal to negative 9.8 over negative 9.8, which is 1 because they're the same thing. So then you have t over s is equal to 1, and then you find out that t is equal to 1 second. So when you throw the ball downwards at 14.7 meters a second from a 19.6 meter balcony, it'll hit the ground in exactly 1 second. Okay, so the ball that's thrown up, now I'm doing the air time for that one, and I'm using the same equation since I have all the same givens. And so now and then I also took it to the same side. So when I replace it, I get the same thing, except now it's not negative 14.7 meters a second times time, it's positive 14.7 meters a second times time. So then you get the same thing except it's positive again. And so in here, the only thing that's changed from before since is the 14.7, and since this one is squared, since you have one of them squared, the only number that's overall going to change in the whole thing is the negative b at the start. So if you get down to here, it's the exact same thing, except this is a negative now. And so again, I did or because it's a plus or minus, except this time, the minus one is correct. Doing minus, sorry, never mind, I'm dumb. So this side, it's negative 14.7 minus 24.5, and that'll end you up with negative 39.2 divided by negative 9.8, which will give you 4 seconds. So instead of negative 4 seconds, you get positive 4 seconds, which is correct since it can be a quantity of time. And then the other answer is incorrect because it'll be negative 14.7 plus 24.5, which gives you a positive answer. So when you divide it by negative 9.8, so you divide it by the same amount but negative, you would end up getting t equals negative 1 seconds, which is impossible because you can't have negative seconds. And so I did the difference by doing the absolute value of one of them minus the other. So the absolute value of 1 second minus 4 seconds. So that ends up being the absolute value of 3 seconds, which ends up as 3 seconds. So now on to B, which is the velocity of each ball as it hits the ground. So the final velocity of each ball. So in ball D, both ball D and ball U, we have the exact same givens, except now we figured out the time of both of them. So ball D has 1 second of time and ball U has 4 seconds of time. And we need to find out the final velocity. So to find that out, I used the first equation because the only one we don't have is final velocity, so we can do everything except the third equation, and the first equation is the easiest. So the first equation being final velocity is equal to initial velocity plus acceleration times time. And so then you substitute everything in. This becomes meters over second, like normal meters over second, because it's multiplied by 1 second. And so then you subtract these together, I guess. And then negative 14.7 minus 9.8, which is, so the initial velocity minus gravity would end up being negative 24.5 meters a second. So that's the final velocity of the ball that's thrown downwards. Now for the ball that's thrown upwards, it's the same thing. Okay, it's not the same thing, sorry. It's the initial velocity being 14.7 meters a second, and then you add that with gravity being multiplied by 4 seconds instead of 1 second. So it ends up as positive 14.7 meters a second, but it's subtracted by 39.2 meters a second instead of just 9.8 meters a second. And you end up getting the same answer, which is negative 24.5 meters a second. So both balls have a final velocity of negative 24.5 meters a second. And so the last question is question C, which is how far apart are the balls exactly 0.8 seconds after they are thrown? So I put down the givens here again, the same initial velocity for them, they have that they all have been, the same acceleration, but now we don't know the displacement, we don't know the final velocity, and the time is 0.8 for both of them instead of 1 and 4 respectively. And so then I did the downwards ball. I used the equation without final velocity because we don't have the final velocity. And so I just substituted everything in, getting negative 14.7 meters a second multiplied by 0.8 seconds plus 1/2 of negative 9.8 meters a second squared multiplied by time squared. So that means that negative 9.8 meters a second squared times 0.8 seconds times 0.8 seconds. And then you simplify it, you can get negative 11.76 meters minus 3.136 meters. And then the overall displacement within 0.8 seconds is gonna end up being negative 14.896 meters. So that means 896 meters downward, so almost hitting the ground. And the upwards, the ball is thrown upwards, you use the same equation, you substitute everything in, except now it's positive 11.76. So this ends up being the same since you have the same time acceleration. And this one ends up being different because you have a positive initial velocity instead of a negative initial velocity. So now you have a positive 11.76 meters minus 3.136 meters, and then you end up getting an overall displacement of positive 8.624 meters, which means that the ball is 8.624 meters above where it started from. And then to ask for the length apart, I did the same thing as in A. I did the absolute value of the difference of them. And so I did negative 14.896 minus 8.624, and then the absolute value of 23.52 is negative 23.52 is 23.52. So after 0.8 seconds, the balls are 23.52 meters apart.